Good morning all. Welcome in Kamla Education Society's Pratibha College of Commerce and Computer Studies, Chinchwad, Pune. Pratibha College organizes a course on image processing using Matlab. Objectives of the course are to study the image fundamentals for image processing, to study different types of images, to study basic operations on image using Matlab. Outcomes of the course are: review the fundamental concepts of a digital image processing system, learn basic commands of image processing, and learn basic operations on image using Matlab. Topics to be covered in this course are basics of image, basics of digital image processing, image file formats, types of images, and basic operations on image using Matlab. What is digital image? A digital image is a representation of two-dimensional array. As we are seeing in the picture, it is a two-dimensional array as a finite set of digital values called picture element or pixels. It means an image is a two-dimensional array which stores the values of pixels. An array is a 2D image is a 2D array which stores the intensity values of the pixels, so their resolution may be in the form of rows and columns. So that resolution may be of 128 into 128, 256, 6 into 256, 512 into 512, 640 into 480. These are some examples of the resolution. Resolution means number of rows and columns present in a one picture. Some common image file formats are like GIF, stands for Graphic Interchange Format, PNG, Portable Network Graphics, JPEG, Joint Photographic Experts Group, TIFF, Tagged Image File Formats, TGM, Portable Gray Map, FITS, Flexible Image Transport System. There are four types of images: binary image, index image, grayscale image, and colored image. A binary image is a logical array containing only two values, that is zeros and 1, that interpreted as black and white respectively. So we can say a binary image is a 2D array having only two values, 0 and 1, where 0 indicate black value and 1 indicate white value. If we want to check it is a logical or not, the image is logical or not, we can check it by the function e. Or suppose A is any numeric array and we want to convert it into the logical array, we can convert it using the function of logical. Here we can see the example. Logical of A means A is an any array that we want to be converted into the logical. So logical A is converted and it is stored in a variable B. If we want to check the image C or an array C is logical or not, we are using here the function is logical. Second type of image is indexed image. Indexed image has two components. First one is the data matrix of integers X, and second one is color map, or we can say color matrix. So it can be displayed in the form of X and map. So if we want to display a color index image, we are representing I am show X comma map. Index image has index file and color map. One file stores the detailed value of the color and one file stores only the color code in the file. That file is called as index file. So index image has two files, index file and color file or color map. So the index file is the index number table that will be mapped in the RGB color value in the color map. So it requires a less storage than we are storing the whole code for the RGB colored image. Next type of the image is grayscale image. It is also called as intensity. It is an image in that we are storing 2D array with the values of between the range of 0 to 255 values. It represents three colors: black, white and gray. It is a data matrix whose values have been scaled to represent intensities. Next type is colored image or RGB image. A colored image is a 3D image. It means we have representing three colors: red, green and blue. To store these three colors in the memory, we required three arrays. One for red color, second for green and third one for the blue color. So an RGB color image is in size of m into n into 3. M multiplied by n multiplied by 3 array of color pixels. Here m indicates number of rows, n indicates number of columns and 3 stands for three colors: red, green and blue. Each pixel is a triplet corresponding to the red, green and blue component of the RGB image. So how we are representing a color image? Color image has three different bit planes to store the color. We are separately storing red, green and blue color in a different array. So when these three values superimpose, then it have a one intensity value of a pixel. Suppose this is an image. In the figure you can see a image is a colored image. When it is stored in the memory, three arrays are stored: one for the only red color combination, second for only green and third one for the blue. So in this format, red, green and blue format, colored image is stored in memory. Some basic operations on image using Matlab. We will see some basic operations on image. So some operations are like: we want to be access or read an image in Matlab, display an image, convert types of images, histogram of image, check size of an image and subplotting of the window. First operation in the Matlab, to read the image or to access the image. If we want to be read an image or access the image in the Matlab, IamRead function is used. IamRead function is read the value and open it into the Matlab. So syntax of it is IamRead in bracket image name dot extension of the name file. Example, B is equal to IamRead papers dot png. Here I am taking one image which is already built in the Matlab. That name is the papers. .png is the extension of that file. It is a png. So here papers.png file I want to be read. So I am using the IamRead function here. IamRead papers.png and store it in one variable B. So B is equal to IamRead papers.png. It is read a one image papers.png and stored it in a variable B. Display an image. If I want to be display an image on the screen, the function is used IamShow. IamShow function is used to display an image. So syntax of it is IamShow in bracket filename.exe extension. Example, I have already read the image papers.png. Now I want to show that image. I can directly write IamShow in bracket filename and dot extension papers.png, or if I have already stored it in a one variable, suppose in the previous example I stored it in a B is equal to IamRead dot papers. So here I can write here IamShow B also. This is the example of read and show an image. I is equal to IamRead points.png. I have read the image points.png and stored it in a variable I. And second command, I am printing or I am showing the image that I have already read. IamShow I. Here I means here I have read the image and stored in I. So here it reads the coins.png image and display it on the screen. There are some file formats that we have used, that is the grayscale, index, and we have some file conversion formats or commands. So color format conversion and commands used in Matlab are like this: int to gray, gray to int, RGB to gray, RGB to int, int to RGB. Int to gray is convert index image into the grayscale image. Gray to int converts gray image into the index image. RGB to gray is useful to convert RGB colored image into the grayscale image. RGB to int is used to convert RGB colored image into the index image, and int to RGB is used to convert index image into RGB colored image. We will see one example how we are converting the types of the images. Suppose we will take one colored image and convert it into the grayscale. In the previous example, we have read the image papers.png. This is the colored image. Now I would like to convert this image into the grayscale. So to convert the colored image to the grayscale, RGB to gray function is used in Matlab. So if I am storing the image in A, which is the colored, I will write the command RGB to gray in bracket A, and then I store it again in a variable B. So B is equal to RGB to gray A. It means I am reading the RGB image and stored it into the B. This function converts paper.png image into the grayscale colored and stored it in a variable B. So the complete command is B is equal to I am read papers.png, which is already a colored image. Then I have converted this image into the grayscale. So I write the command B gray is equal to RGB to gray in bracket B. Here B is a variable where I store the papers.png image. Now I would like to display this image. So I write the command figure, means another separate window I want here, and I am show is used here to display or to show the image. So I am show B gray will display here grayscale image. Next operation is image histogram. An image histogram, it is a distribution of gray levels and it represents how many times it occurs. So to represent the image histogram, the Matlab function is used here is IamHist. Syntax of it, IamHist in bracket file name. So already suppose I have used stored the image papers.png in variable A. Now I would like to show their histogram. So I will write the command figure, comma, IamHist A. Figure indicates here a new image with the histogram. So here I have taken suppose f is equal to I am read coins.png. Here I read coins.png image and stored it into the f variable. Next command indicates figure, comma, IamHist of f. So it will show histogram of the image coins.png. Next operation is Hist Equalization. Hist EQ is the function used for histogram equalization. So Hist EQ is the function to spread the intensity values over the full range of the image. Example of it, A is equal to Hist EQ of I. So suppose I is a one image and I want to show the histogram of that image which is in a equalization form. So I use the command Hist EQI that's stored in a variable A. Next command is to check the size of an image. At the start, I don't know what is the size of an image, what is the resolution of an image. Size means nothing but the resolution of an image. Resolution means number of rows and number of columns representing in an image. So to check the size of an image, size function is used by the Matlab. We will see an example to check the size of an RGB color. As we know, RGB color is in the form of M into N into 3. M stands for the row, N stands for the column, and 3 is the for 3 colors, red, green and blue, because RGB colored image is stored in the form of 3 arrays. So example, B is equal to I am read papers.png. Here we have used one image, that is the papers.png, and stored it in a variable B. Now I want to check the size of this colored image. So I write the function size B. It will tell me the size of that RGB color, and the answer is here 384 512 3. It indicates 384 as the M, that is the row, 512 as the N, it is a column, and 3 it is a colored index. So it is the size of an index, size of an size of an array. Size of an array is 384 multiplied by 512 multiplied by 3. Now we will check the size of a grayscale image. As we know, colored image, it is in form of m into n into 3. Now we want to check the size of a gray image. First we are reading the image papers.png and stored it in a variable b. Then we convert that image into the grayscale and then we will check the size. So commands that use b is equal to imread papers.png. It will read the papers.png image and store it in a variable b. Now that b variable I have converted as a RGB to gray and stored it in a b gray variable. So b gray contains now grayscale image. Now I want to check the size of that b gray. So I will use the command here, size in bracket b gray. Size b gray will tell me the size of the grayscale image. So answer is here 384 512. When the image in your color format, their size is m into n into 3, but when it is stored in a grayscale, the size is only in the form of m into n. So here the size is reduced when we are storing the RGB colored image into the grayscale. So in many image processing operations, before to perform operations on the image, that image is converted into RGB to gray color format to reduce the size of an image. Next operation is the subplotting of the image. Many times in an application, I would like to display 4 images in one window. So subplot is a command that plotting me the window in the given parts and I am able to display the images in that portion. So to subplot the image, subplot function is used. Example, subplot 2, 2, 1, I am show A. Suppose in I am show A, I have stored one image that is the cameraman.c as we are seeing in the image. First image I stored cameraman, second one is the one child's image and third one is the paper's image. So its image are stored in a B and C respectively. Now I divide that window in the 3 parts, 2 into 4 parts actually, but I am representing only the 3 images here to know that. So subplot 2, 2 indicates I am subplotting the image into the part of 2 by 2. Means total 4 portions are there on the image. In the first portion of the 2 by 2, I stored first part as a camera. I am show A, it indicates the cameraman's pictures. Now another part where I display the child's photo, child's image, I am plotting subplot of 2. I use the second part, that is the 2. And I am representing the image B. So the command will be like subplot 2, 2, 2. Now in the third part of the 2 by 2, I would like to display the papers.png command image. So I use the command subplot 2, 2, 3 and I am show C. Here C is the papers image and in the third portion of this part I am displaying it. If I would like to now the fourth part, I would like to use the fourth part here. I will write subplot 2, 2, 4 and here the image that I would like to show. So suppose I would like to show the image D here and that D image is suppose coins, so that image will be displaying this portion, the fourth part. It indicates the part of the image. It indicates in the how many portion parts we are divided the window. So subplotting of the image is able to display your multiple images in the one window. Another example of the subplotting of the image is subplot 1, 2, 1. I am show A. In this we have divided the image into 1 by 2. Means only 2 portions. And out of that first portion will display the image A. So subplot 1, 2, 1 indicates subplotting the image into 1 row, 2 columns. First indicates the rows and second indicates the column here. So 1 by 2 it is converting into the 2 parts, 1 row and 2 columns and store that image A in a first portion of this one. Portion means in the second column I would like to display the image B. So I will use the command subplot 1, 2, 2. I am show B. It will subplot the image into 1 row and 2 columns, and out of that the second part stores the image B column. So here I am still here A. It is stored in the B in the second column. So in this, these are the some basic operations that we can perform on the image. Here some references I have enlisted that I have used to prepare this PPT. These are some books that we can use while we are performing the image processing using Matlab. Thank you.